So in doing these radicals, the idea is that like the square root of 12 is not what we call a perfect square. That list on the board, those things that you guys just rattled off are all perfect squares. 25 is a perfect square. Okay, because the square root of 25 is 5, right? The square root of 49 is 7. So 49 is a perfect square. But 12 is not a perfect square. So what we need to do when we don't have a perfect square to simplify that is we're going to create what's called a factoring tree. So we're going to take 12 and split it up into numbers that can multiply to be 12. And you can do any numbers you want. So what numbers can you multiply to get 12? 6 and 2. Okay. So I heard 6 and 2 first. I heard somebody else say 4 and 3, and that would work also. Because you have to keep splitting up all of these numbers until you get down to prime numbers. For example, 2 is already a prime number, so I'm going to stop with the 2. But the 6, I have to keep going because 6 is not prime. Prime means it's only 1 times the number. So what can we multiply to get 6? Yeah, 3 and 2, right? So we have 3 and 2, and now I have all prime numbers. So you want to put multiples until you get all prime numbers. Once you get it down to prime numbers, you look for pairs. So we have 2 of those 2s. When you have a pair goes on the outside of the radical. So those 2s mean we have 2 on the outside. Now this 3 doesn't have anything to pair up with, so that guy has to stay home. And so our answer is 2 times the square root of 3. And that's the answer. Okay, the answer is written that way, 2 radical 3. Okay, again, the 2, because we had a pair of 2s, those go on the outside. And that 3 was left over, so that guy has to stay home. So let's do the next one. Let's do the square root of 48. All right, give me 2 things you can multiply together to get 48. 24 times 2. All right, good. And you know what? Some of you guys are better with the multiples than others, but we know 48 is even, so you can always divide it by 2, right? So we can do 24 times 2. So now that 2 is a prime, but the 24, of course, is not. So what can we split up 24? 4 times, I'm sorry, I can't hear you. 4 times 6, okay? Neither of those are prime, though. So we have to split those guys up. So 4 is going to split up into 2 times 2. Those are both prime, so that's good news. And 6 splits up into 2 times 3. Okay, so we just want to keep this process until we get all prime numbers. And once we get all prime numbers, then again, we look to partner them up. We have those 2. That's going to give me a 2 on the outside. We have those 2. That's going to give me another 2 on the outside. And that 3 has to stay home. And so our final answer will be 2 times 2, which is 4 radical 3. Okay, so we do this prime factoring. Pairs go on the outside. Leftover stuff stays underneath. All right, let's do the next one. We have 72. So, 72 is even, so I could do 2 times 36, right? 72 would be 36. So I'll split that up into 2 and 36. Now 2 is prime, so that's good, but I have to split up 36. And that's even also. So I could just kind of play the even game and split that up into 2 and 18. And 18 is even, so I could split that up into 2 and 9. Now 9, of course, is not even, but that's a pretty easy one to factor into 3 times 3. And so now I have all prime factors. So I want to look for pairs. So I'll take these two, give me a 2 on the outside. These 2 3s give me a 3 on the outside. And don't forget I have 1 2 left over, so I have to leave that underneath. I know that gets kind of messy. Our final answer will be 6. That's 2 times 3, so 6 times the square root of 2. All right, so any questions on the first ones? No, we're good so far? Excellent. Because the only difference between the first ones and the second one is, the second row is here, I have this 2 out in front. So what I do is just ignore that number out front. For now, I'm going to ignore it. And then when I'm done, I'm just going to multiply the outside stuff by 2. So I'm just going to do a factor tree for the 18. So I know that that could be 2 times 9. Okay. And 9 would be 3 times 3. So just like before, I did a factor tree for the 18. So now I have a 3 that's going to go on the outside. I have this leftover 2, so that's going to be a square root of 2. But now don't forget to bring down that 2. Okay, so after I do the factor tree, that 2 up front, I just multiply and bring that 2 down. So my final answer then is going to be 6 square root of 2. All right, so I'll do one more and then I'm going to have you guys practice a couple, okay? All right, so to do problem 5, again, the 3 out front, I'm going to leave till the end. Okay, so I'm not even going to mess with that 3 out front. I'm just going to do my factor tree for 56. I know that's even, so that's going to be 2 times 28. And 28 is even, so that's going to be 2 times 14. If 14 is even, that's going to be 2 times 7. Seven is actually a prime. So I have now factored it all the way down where I have all prime numbers. So I'll take that pair, those go on the outside, that's going to be 2. Now for the 2 and 7, this is a little different because this guy doesn't have a pair and this guy doesn't have a pair. So I have to leave both of them underneath, but I multiply them back out. So I do 2 times 7 underneath because neither one had a pair. And then don't forget I have to bring that 3 down from out front. So our final answer will be 6 square root of 14. So on the last couple that we did, you know, you guys are doing a good job of your factor trees when you are dividing by something. So for example, you know, most of you look at, say this last problem we did and say, okay, well, 56 is divisible by 2. So that's a good idea. You can use your calculator and divide it by 2, but it's not divisible by 2. Then try 3. And if it's not divisible by 2 or 3, then try 5. And you want to work your way through the primes, but it almost always works with either 2 or 3 or 5. And then sometimes 7 or 11 or so on, but typically those 3 work. Now, in the next section, it's similar, but we have a couple of different parts. I don't know if you're going to think this is harder or easier, but what we want to do is we want to multiply these things. And there's many ways that we can do this. Okay, the first thing is things that are underneath the radical, like the 2 and the 6, we can multiply those and write that as 3 times the square root of 12. I got 12 by doing 2 times 6. I got the 3 from this guy. So this is one way to do it, is to multiply them together. And now it looks just like one of the problems that we were doing. Okay, the 3 we're going to leave for the end. And we're going to take the 12 and do our factor tree. So I know that that could be 2 and 6. 2 is a prime. And then 6 would be 2 and 3. So I have it down to all prime numbers. So once we have it down to all prime numbers, I pair them up. That 2 goes on the outside. This 3 doesn't need a pair. Remember, that was on the outside already. And then this guy's left over. And so our final answer would then be 2 times 3 is 6, square root of 3. Okay, so kind of one more step from what we were doing. Is I just multiplied the 6 times 2 and got 12, and then went from there. So in problem number 2, I can do, you know, something similar. Multiply anything on the outside. So 4 times 5 is 20. And anything on the inside, 2 times 20 would be 40. So I just multiplied outside stuff and inside stuff. And now it looks just like our previous problem. Okay, we're going to leave the 20 for the end. But we'll do our factor tree for 40. So I know that 40 is even, right? So I'll make that 2 and 20. I'm going to make 20 2 times 10. And I make 10, 2 times 5, and now I'm down to all prime numbers. So I'll pair them up. That 2 is going to be a 2 on the outside. I have that 20 that I'm going to bring down. Then I have the 2 and the 5 left over, so don't forget you have to multiply those. And so then our final answer will be 40 square root of 10. Okay, so if we're multiplying, we can multiply stuff on the outside and multiply stuff on the inside. If we're dividing, like in problem number 3, these are both inside, so I can just divide those numbers. Well, 42 divided by 7 is 6, and so look at this one, it's a quick one. The answer is the square root of 6, which can't be simplified. Okay, because they were both underneath the square roots, we could just divide both of those. And number 4, we can't do that because the 5 is not underneath the square root. So I can't just divide 125 by 5. So in that case, we have to treat it as I'm going to do the square root of 125 first, like we were doing before. So I'm going to write that off to the side. I'm going to do this and do a factor tree for just the top. Well, it's not even, so 2 doesn't go into it. So then I break out my calculator and try and divide it by 3, but 3 doesn't go into it either. So if 2 doesn't work and 3 doesn't work, try 5. And 5 actually does work because 5 times 25 is 125. And then that 25, I can split into 5 and 5. So now I have all prime numbers. And so for those pairs, I get 5 on the outside. And I have a square root of 5 left over. But remember, that's only the numerator. That's just the top. The bottom, don't forget, that's all divided by 5. Okay, because we have to put that bottom there. So we just did the top independently and then put it over the bottom. And now our 5s actually will cancel. And so our final answer is just the square root of 5. Just a little different twist with those when we're multiplying and dividing. But remember, stuff that's on the outside goes together and stuff that's on the inside goes together. All right, any questions, guys?